Hello friends, welcome you all for the session 33rd of the Mumbai development. So in this lecture we are going to be seeing a different world of modules which are going to be part of the APB bus that we talked about in the last lecture. So these are all about peripherals. Okay, so there are plenty of peripherals and it will not be humanly possible to cover all of them, and there are plenty of implementation too from based on which company is giving and what kind of features they are supporting in those peripherals. So my intent of this lecture is to give you an overview of the major important categories of peripherals and their high level functionalities. Maybe I would have referred some specific implementation which I am referring to that in the note below, but these features what I am listing here may not be only restricted to this. It could be more than what I am giving here, or it could be a subset of this, or there may be some changes to those features which are there in a particular category of peripherals. So what I am going to be sharing in this lecture is only an overview and then a likelihood of what other features could be supported in those peripherals. So it is not limited to that what I am listing here, and you may have to refer to a particular implementation of a peripheral to know what all the features are supported and how to program them, because each peripheral, each implementation may differ in terms of how to program them. So I am not going into details of which registers and which pins need to be, which bits in the registers need to be configured, because that is not universal and it is not specific to it's not accepted standard. Maybe there are some conditions, but mostly it is implementation dependent. So you may have to look at the documentation of particular implementation to configure a particular peripheral. So here let us see what all the peripherals are there and how we will give you some overview of each of them, so that when you go and read some manual of particular implementation, you will be able to appreciate what is supported there. So the rest of the lectures are going to be 2 lectures on peripherals and some interconnect protocols, and then we will conclude it with a few details on the feature family of the latest advanced ARM family of processors. Okay. So in this lecture we are going to cover this following thing. I am sure all of you would have heard about it or used it in somewhere or the other, the direct memory access, DMA. So let me just give you an overview before we go into details. So maybe I am sorry about this particular. Okay, let us see. I have a picture, and which will give you some more details. So I can explain more details about DMA, where exactly it is used. Okay, so let us go into the slides. So DMA is used in order to provide high-speed data transfer. Okay. So as the name suggests, it is directly accessed, okay, from the memory. So so far we have been saying that if you need to access a memory, the processor in the system needs to give the address out, okay, and then the memory will give a data back. Okay, this is what we have been told or we have been discussing. Okay, this is the address. Who has to give the address? It is the processor. Okay, and then the memory as a slave device. This is behaving like a master, the processor, and then drives the memory cycles either LDM or LDR or STM or SDR instructions. So memory gives out the data, or maybe we can write into the memory. But this is not the case always, because if you want to involve the processor for every transaction in the memory, then it is going to slow down the whole system, because processor has some other important things to do other than copying or taking from memory. So to speed up this, the concept of DMA came. That is called direct memory access. The memory is accessed directly, not through the processor. Okay. Now you may wonder who wants to access it. It could be that this is a ASB bus. Let us assume that this is AHB. Okay, now I can say what bus I am using because you are all familiar with the AMBA architecture now. So APB bridge is here, and then the APB bus is there on this side, and then assume that there is a controller. I will call this as a disk controller. So sometime maybe disk controller could be on AHB, but let me assume that this is accessed through this for a moment. Okay, or it could be a serial port also. Yeah, we can have a serial port, and then you are a serial port controller, and then the serial port is connected. But if there is a need for a transfer of bulk of data into memory, okay, from some peripherals, it could be a disk controller or it could be a user. You are maybe we know it's a PC connected to this. So suppose programmer wants some buffer of data, maybe a few bytes, it could be few bytes, or it could be on page of memory data or code maybe needs to be copied into the main memory. I am calling this as a main memory. Now one way of doing is initiate the transfer, okay, copying from APB to some register here and then from register to memory. So you can see that if you need to copy a character coming from a peripheral and to be written into memory, the peripheral is a slave device, so it needs to be accessed by someone. So it could be the processor. So ARM can access the peripheral register because it is all mapped to a memory, but you can't do a memory to memory transfer. Memory to memory transfer, if you have noticed, no instruction in the ARM supports this. Well, that is not the kind of a RISC instruction. Okay, RISC instructions always have a processor register to memory or memory to processor register, but there is no memory to memory to transfer. That instruction itself is not supported in any RISC families of processor. Maybe few of them will have that a unique combination. So there will be always a exception for these kind of rules, but in general, RISC family of processor, and in particular in ARM, we have the LDM and STM instructions, which are the only load store instructions with the memory. That also it transfers to and fro from memory to register. But our intent is to get some few data, blocks of data or a page of data into memory. So that is from peripheral to memory. So that cannot be done directly from peripheral to memory unless we introduce a new block in the discussion. Okay, that is called DMA. So what the DMA does, the processor accesses this as another module in the bus. It could be another coprocessor or it could be implemented in any way you want, but this registers are, it could be accessed as a peripheral also. Okay, that means it is part of the memory. These registers are mapped to a particular part of the memory. So we could write into this some details so that DMA takes care of transferring from maybe UART here to a memory. So to do this, somebody has to initiate it because this is not it will behave like a master, but somebody has to initiate it. It can't do it on its own. So that is done by a processor like ARM, or it could be done by another processor. If it is a DSP processor, it is also a master there. You know that AHB bus can have multiple masters. So if DSP wants to transfer some data from maybe a speaker or some device or video card, and then it wants to put the data into the memory before the DSP can process the data. So even the DSP processor can initiate it, but one of the other processors who can be programmed can initiate a transfer. What they do, they program the DMA with some information. So what are the information that they need to give for a transfer of a data? Okay, let me choose some other color which will be seen by pretty clearly. So the intent is okay. Same looks like same. Let me take a look. Okay, this is the maybe a peripheral. Okay, some memory, some peripheral. Okay, and this is the memory. Now start from here. Maybe you want to say that I want some data from this register. Maybe okay, because it will be replenished from the device. Okay, some device is there, so this it will be writing into one word is written into that from the device. Once it is copied from to the memory, one more data will come. So we have to say what is the start address. Okay, it could be the same address, and then where is the destination address, source and destination. Okay, it may be a source. Okay, address, source address and the destination address. So this is what we are providing to the DMA. Okay, and then we will say that what is the length of data from this source address. You copy into the destination address this much of length of data, maybe 10, 100 words. So what will happen is, if suppose it is coming from a device which is supposed to be giving packets of maybe a network device which is giving you 100 words at a time, it is supposed to give 100 words. Assuming that, then we can configure the DMA. Okay, saying that you copy starting from this peripheral address to the start. Now you block some part of the memory and then make sure that it is not taken out, swapped out, or it is not used up by some other process. So it should be free of any access. Okay, it should be only accessible to the DMA, preferably the regions and other things. The right permission should be there, but it should not be overwritten by somebody other, some other process or some other peripheral. So we should lock it in this particular area of memory. Then we can tell DMA, the ARM processor does it, inform the DMA programming the destination address and the start address and the length of data to be copied. So if it has to be from where it has to be read and where it has to be written to. Once this is given, the DMA starts off where without involving the processor. That means ARM is free of this transfer once it is written. Once it is passed on this information to DMA takes care of transferring it. After the complete transfer is done, it will interrupt. So then, and the handler will come and then look at the data, then inform the particular process which is waiting for the data. Then it will take on to the processing. As I told you, any processing needs to be done by ARM. That data has to be in the main memory. It can't be in a disk, or a peripheral, or it could not. It can't be in peripheral registers, and you can use it for processing it using ARM instructions. So before that, it has to come to the memory, and the responsibility of copying the data from the peripheral to memory is given to the DMA. So once the DMA is programmed, whenever the AIT bus is free of any other transaction, the DMA also tries to get the bus. The arbiter will be looking for all the masters. This is one master here, and this is another master, and ARM is another, maybe third master. The three masters are there. They will be sharing the bus among themselves. And then once this is programmed, it will start off with the copying of the data as soon as the data is available. So it needs to be available, and then it will come and then get programmed and copied. So this is what happens. This is what is done in a DMA. So I hope this is clear. So it could copy from peripheral to memory, as I explained, or it could do from memory to peripheral,